Any class on statistics should have at least an introduction to probability. Probability in itself is a much larger topic, and we will only really kind of scratch the surface and talk about it in general terms. In this section, we'll cover the general concept behind probability. We'll take a look at counting measures and how we count in probability. Mutually exclusive and independent events, define and determine how we separate those. We'll go back to your math knowledge and dig up factorials. In factorials, we'll also look at the combinations such as permutation and combinations. We'll look at expectations, but the expectations will also be covered in more detail in the example problems that we'll cover in class as well as in the homework. And then finally, we'll take a look at conditional probability and conditional probability tables. So let's get started here. Probability language is quite common in our vocabulary. We use words such as chance, probably. Sometimes we talk about insurance as being too expensive. Well, that implies some probability of an event happening. But probability is simply expressed as the fraction, as a fraction where the denominator is the total number of ways things can occur, things can happen, and the numerator is the number of things that you're looking for. So it's really quite simple. If we take a look at this equation, we think about flipping a coin. The denominator is the number of possible events. Well, there's only two possible events. It's either a heads or it's a tails. If we call heads, well, we're looking, or the event that we're looking for is a heads. There's one way that the coin could have a heads. So we would say that the probability of a heads is equal to 1 over 2, or 1/2. And that's a very simplified example, but that is what probability is all about. It's counting the number of things that we're looking for divided by the total possible ways that it could occur. Now, we can't calculate all probabilities, and so there's basically three approaches to probability statistics. The first is a classical approach. Classical approach is just like I just described with the toss of the coin, where we're just counting the number of things and dividing by the total number of things. Sometimes we can't really get a good idea, or we can't calculate those things, and so we have to use a relative frequency approach. And then finally, when events are so rare or occur so often, we might use a subjective approach. So let's take a look at those three different ways of approaching probability. What is the probability of getting a 3 on a 6-sided dice, or a 6-sided die? So we would say that the probability of a 3, well, there's only one way that we could get a 3, but there are 6 total outcomes that could possibly happen. So we can use a classical approach, and a classical approach is preferred because it's deterministic. We can calculate that without a lot of error. Relative frequency approach occurs where we can't really calculate the probability. So for example, if you want to know what the probability that you'll hit a stoplight is, you can count up or measure the total number of time through an entire cycle, and you can measure the amount of time that there's a red light, and that will give you a relative frequency. In this example, what is the probability of randomly selecting a student in this class, and that student being a female? Well, I really don't know exactly what that possible outcome would be, but I could count up the number of students and count up the number of females and get a relative, or a relative frequency. Now, sometimes these events are rarely happen or they haven't happened yet, and so we can only use a subjective approach. So what is the probability that you will die doing statistics? Now, the notation that I've used here is actually a conditional notation where the first doing statistics is the outcome and death is the outcome, and doing statistics is the conditional outcome. So if I'm doing statistics, what's the probability that I will die? Well, I really don't have any way to measure that from a classical or even a relative approach. But my intuition tells me that the probability of that happening is so low. And we could use a relative approach. We could go back in history and measure the number of times people have died while they were doing statistics, but I don't know that that's measurable, so we would assume that it's very low. Now, what's the probability you use your computer for something other than statistics during this class? Well, that's pretty high. So if you're sitting in class and you're listening to me talk, there's really a temptation there to see what your friends are doing or check out Facebook or other social media. And I'm pretty sure that you're going to be at least looking once in a while, and so the probability of that would be pretty high. So I've given you a few examples here, and just mainly as a thought process, which of these three approaches would most efficiently use to find the probability of an event? Getting snake eyes and crap. Snake eyes is double ones. So I could count up the number of ways that you could roll 2 dice, and then I could divide it by, or there's only one way that I can get a snake eyes. So in this case, the probability of snake eyes using a classical approach would be 1. There are 6 ways that I can get 6 different numbers that I can get on the first die, and there are 6 different numbers that I can get on the second die. These are exclusive events, and so the probability of getting snake eyes is 1 out of 36 using a classical approach. Hitting a green light on the intersection, once again, that would be a relative approach. I could measure those times and get an idea, but it would not be statistically accurate in all cases. What's the probability of dropping this course? Once again, probably here would be a relative frequency. I don't know what your personal situation is, but I can look at the history of students that have taken this course and dropped it in the first 2 or 3 weeks, and I can get a relative probability of what that is. Teen suicide, picking the winning number in the lottery, especially picking the winning number in a lottery. I guess if you knew those numbers and you could calculate those probabilities, the classical approach might be used. But I would probably just start with the subjective approach and say the probability of winning the lottery is very low.